Hi everyone, welcome back to Life Technologies channel and thank you for watching. So we've been exploring how you can use different BGP path attributes to control traffic flow in the network. And in our last two episodes, we demonstrated how you can use local preference and preferred value to control traffic flow in the network, mainly controlling the outbound traffic from our client network to the internet. So in this episode, we'll be concentrating on how you can use BGP AS-PATH attribute to control the traffic flow from our client network to the internet. So as you can see from the topology, our client network is connected to different ASs. We have ISP1, which is in S300, and we also have AS400, still part of ISP1. We have AS200, ISP2, and then we have ISP3 in AS500, and the internet is in AS600. Our local client network is in AS100. So BGP AS-PATH attribute is a very common mandatory transitive BGP attribute that is carried in all the exchange messages when the routing information is being exchanged from one AS to the other. But before we demonstrate how we use these path attributes, we need to understand what it is. So let's start by discussing what AS-PATH attribute is. So the AS-PATH attribute always record all the ASA that a route passes through from the source to the destination in the vector order. So when the routing information is moving from one AS to the other, it will always have the AS-PATH attribute. And to prevent inter-AS routing loop, AS-PATH is always used to control loops between ASs. So a BGP device does not receive the routes of which the AS-PATH list contains the local AS number. So when a local device is advertising a route to other ASs, it will add its own AS. And by any chance that it's learning the same route and the route has its own local AS, it will drop the route. So that is what it means. It's being used to prevent the inter-AS routing loop, where if a device does not receive, the device does not receive the routes of which the AS-PATH list contains the local AS number. So whenever there is the local AS number, the route is dropped. And this one helps to control loops in the network. So when a BGP speaker advertises imported routes, first, if the route is advertised to eBGP, the BGP speaker creates the AS-PATH list containing the local AS number in an update message. So when you are exchanging the update messages, it will always include the AS-PATH number. And this is only for if it is being advertised to eBGP. If the route is advertised to iBGP peer, the BGP speaker creates an empty list in update message. So when the route is being exchanged from iBGP to iBGP peer, the AS-PATH list will be empty and will only include the AS-PATH information that was learned from the external BGP peering. So if the route is advertised to a BGP peer, the BGP speaker adds the local AS to the leftmost of the AS-PATH. So to the leftmost, remember. So if we were to check on R1, if we log into R1, and remember we have a route to 172.200.200.1. So if we check on R1 and display BGP routing table, that IP 172.200.200.0, you can see that we are learning two routes. And these two routes have the AS-PATH information. So we said, remember the route has been advertised from, I need this snippet, the route has been advertised from 600. So when R11 is advertising this route to R9, it will attach the AS number of 600 to the leftmost. Remember, this is the source AS, so it will be the leftmost on the AS-PATH list. This route is advertised from 500 to 400. So when R9 is advertising this route to R7, it will also append its AS number to the leftmost, so it will append on 500. And then R7 will advertise this route to 300. So R7 will also append its own AS 400. R5 will advertise the route to R1. When R5 is advertising the route to R1, it will also append its own AS. So 300 will be appended here. That's why if you check the route that we are learning from R5, you will find that we have this AS path list. So on R1, you can see that we are having a route. This is from R5. We have 600, which is the source AS, and then we have 500, 400, 300. On the other direction, it's the same. When this router, I will use a different color. When R12 advertises the route to R10, it doesn't change the AS number. Remember, that is IBGP. So, no, the AS path list will be empty. But then when R10 advertises the route to R9, it has to append the AS number of 600. Then R9 will advertise the route to R6 and append its AS number. This is 500. When R6 advertises to R1, it also has to append the AS number of 200. So this will be 200. So the source AS is 600 for both cases, but you can see the different AS paths that the route has followed. So when R1 is selecting the best path, it will select the path with the lowest AS number. So that's why if you check on R1, you will realize that the route that is learned from S200 is preferred compared to the route that is learned from AS300, because this one has a shortest path. So when the AS path is the tiebreaker, we always select the path with the shortest AS path, and that's why we've selected the lower path and not the upper path. So when this route is advertised to R1, to R4, if we display BGP routing table 172.200.200.0, you can see that we don't have AS100 here because this is IBGP route exchange. It doesn't add the local AS number. But when it is advertised to the external network, then the router has to add the AS number to the leftmost. So we know that our traffic is flowing from R4 to R3 to R1 to R6, R9, and then R10 because the lower path has the shortest path. So we can make the lower path to have a longer AS path so that the traffic will flow from R1 to R5. So we can do what we call the AS path prepend. We are taking the route that we are learning from AS200 and then we are adding the AS path. We make it longer so that when R1 is selecting the best route, it will select the route that is coming from R5. So the way we do it is very simple. First, we'll be using a route policy again. Remember, we have configured an IP prefix in our previous lab. So we'll be using the same IP prefix. And down here, we are creating a route policy we are calling append AS path. And then we are merging the IP prefix and we apply AS path of 200, 200, 200 additive. So we are adding 3 200s on the leftmost of the AS. And then we are using the route policy. We apply it on the BGP peering towards router 6. So once I apply this, we expect that the path that is coming from R6 will have a longer AS path compared to the route that is coming from R5. So on this router, I will apply the policy. So I've applied the policy, display current configuration, configuration BGP. You can see that we have applied this policy. And now if I go ahead and check the routing table, display BGP routing table of 172.200.200.0, you can see that now the upper path is preferred. Why? Because now it has a shorter local preference. The one from R6 has a longer local preference. You can see we have appended 203 times. So we've made it longer because this is 1, 2, 3, 4, 5, 6. It has 6 AS, so it's longer compared to the one with 4. So the one that is coming with the AS-PATH of 4, it will be preferred compared to the one that is coming with the AS-PATH of 6, which we have prepended multiple AS numbers or need to make it not optimal. So if we do a trace, we expect traffic to use the upper path as expected. You can see the traffic from PC1 to PC2 is now following the upper path. But if we check on R4, display BGP routing table, we can just recall the same command. You can see that when that router is advertising the route to PC1, still it only advertises the best route, the one that is following R5, because currently that is the best route. So with this AS-PATH prepend, we are able to control the traffic flow of our network, of our client network, such that it can follow the one with the shortest path, because we have already made the lower path to have the longest path, making the upper path to have the shortest path. So this is how you can use BGP AS-PATH to control the traffic flow in the network. And remember, the route with the shortest AS-PATH will always be preferred compared to the one with the longest path. And remember that it's very easy. You just need to create a route policy, and then you use the route policy in the import direction. Remember, we are only doing this in our client network that we have control over. So thank you for watching again. If you have any question, feel free to leave it in our comment section. Please subscribe to our channel and stay tuned for more upcoming videos. Thank you.